All right. So now, solve the following system. So this is, again, example 4 on our note. All right. And again, solving the following system means finding the point of intersection. All right. Now, again, I have two lines here. I have y equals negative 4x plus 10. And my other line here is y equals 3x minus 22. Now, here's the whole trick of this. All right. If you get this concept coming here in the next minute, it won't be that bad for you, I don't think. All right. Now, again, I said with the point of intersection, it's special because they have the same x and the same y at the same time. All right, so I'm going to write these equations a little bit differently. I'm going to write this negative 4x plus 10. I'm just going to write it backwards, equals y. All right, now at the point of intersection, so at the POI here, here's something important. This y here, and this y here are the same. So I'm going to make y equals 3x minus 22. All right, because they have the same y at the same time, same x and the same y at the same time. So these two equations are both equal to this y. So if this is equal to y and this is equal to y, then in fact, they're equal to each other. That is the most important concept for what we're doing right now. All right. Point of intersection, the same x and the same y at the same time. So that means that these two are equal to each other. Now, what we have here is an equation where we can solve for x because there's nothing but x's here. And so what we're going to do, again, when I'm solving the equations, I'm going to move all my x's to one side, all my numbers to the other. All right. So I got negative 4x plus, whoops, I'm getting rid of that 10, so I'm not going to put plus 10. The 3x is coming over, right? So changes side, changes sign. All right, I have this minus 22 here. You got to watch your signs. Now this 10 is moving over. So it changes sides, it changes sign. So I have a minus 10. All right, and so let's see here. I've got minus 4x minus 3x. That's minus 7x. Then we have, let's see here. Whoops, I think I wrote the question down wrong here. Whoops, it's minus 32, not minus 22. Let's fix that before I get calculating here. There we go. Throw a little tail on it. All right, and so what I have here is minus 32 minus 10 minus 42. All right, again, to get x by itself, I got to divide by the numerical coefficient. So I got a minus 7. And what I do to one side, I got to do the other. Those minus 7s divide each other out. And what our x value is, well, I get two negatives here, so it's going to be a positive answer. And minus 42 divided by negative 7, I believe, is a positive 6. What we just found out was the x coordinate for the point of intersection. Now, they both have the same x and the same y at the same time. So I want to find out the y that they have together. Well, I have two equations to find out that y. So I can put this 6 into this equation or this equation and get my y value for the point of intersection. Again, it doesn't matter which equation you use because they have the same x and the same y at the same time during the point of intersection. All right, so I'm going to sub it into, I'm going to go with number 2. Not that it matters. So I'm going to sub x equals 6 into line number 2. All right, so I have y equals, well, I'll write it down here, 3x minus 32. All right, so I know my x value is 6. I'm going to substitute that in. So I got 3 times 6 minus 32. And let's see here. So 3 times 6 is 18 minus 32. I got to use my calculator here. What do we got? 18 minus 32. I believe that is minus 14. And so now I just found the y coordinate of my point of intersection. So now all I have to do is finish it off and go, okay, my point of intersection is the x coordinate is 6 and the y coordinate is negative 14. And what we just found out was the x and the y that these two share at the same time, the point of intersection, when they crisscross. They have the same x and the same y at the same time. And it happens to be 6 and negative 14. And that's where they would meet. One of the reasons we're doing this algebraically is because we can't graph these. These things are too huge to graph on a graph, right? You look at equation number 2 here, y equals 3x minus 32. We'd have to go down 32 spots on our graph just to hit the y-intercept and then start graphing. So it'd be too big, and that's why we're doing it algebraically. Any questions about that? I'll check my chat here. Let's see here. Nope. All right. So I'm going to do another one. I'm going to do, like I said, example number 3 on the, I'm going to do example number 2, actually. Example number 2. All right. So I'm just, give me a chance here to erase this. All right. So let's get rid of this. So I'm going to do, like I said, I'm going to do example number 2, which I actually think is harder than example number 4. So usually when I teach it, I switch them. Just have it written down in my note a little differently. All right, so it's nice and dry. All right. So our 2 equations. Number 1, we have y equals negative 3x plus 11. And our second line here is y equals 1/2 x minus 3. All right. Now, the reason I have this as a second example is because there's a fraction there. That's why this one's tougher. So again, the only time that I leave a fraction is when I got the slope and I actually need the slope to graph because I want to know the pattern of the line. I want to know how much goes up or down, how much goes left or right. I don't need that here. I'm not graphing. So this 1/2, I'm going to make that a decimal. And so I'm going to change this equation. A half as a decimal, 1 divided by 2 is 0.5. So I'm not going to use that equation anymore. I'm going to use the y equals 0.5x minus 3. So I didn't change the equation. I just changed the way it looked. Now, again, the start is the same. At the point of intersection, we have negative 3x plus 11 is equal to the y, which is equal to 0.5x minus 3. But again, because at the point of intersection, they have the same x and the same y at the same time, this y, these two y's are the same. So if this is equal to that y and this is equal to that y, well, then they are equal to each other. Now, just like before, I have an equation where I can solve for the x value, find the x coordinate of our y, of our point of intersection. So again, to solve for x, I'm going to get my variables all on one side, my x terms on one side, numbers on the other. All right. And so let's see here. I have minus 3x. The 0.5x switches sides, so it's going to switch sides. It's going to be a minus 0.5x. On the other side, I have my numbers. I have got to watch your signs here, minus 3. And then the 11 is moving over, so it's going to be a minus 11. Okay. Putting these variables together again, I have minus 3x's, minus a half x's. So I'm going to be down 3.5 x's. All right. And then on the other side, I have minus 3 minus 11, which gives me minus 14. And again, to solve for x, I am going to divide by the numerical coefficient, which is the number in front of your variable, minus 3.5. What I do to one side, I got to do the other. And so these minus 3.5s divide each other out. And let's see, my x value, it's going to be positive. I got to do 14 divided by negative 3.5. Got a decimal here. Let's see here. My calculator, I get a positive 4. All right. There's the x coordinate of my point of intersection. Now I got to find the y coordinate. Again, I have 2 equations that I can use to find that y coordinate because, again, they have the same x and the same y at the same time. If I had to pick, I'm going to stay away from the decimal. So I'm going to pick number 1. So I'm going to sub x equals 4 into line number 1, which again is y equals negative 3x plus 11. All right, so I substitute in my x value. I have negative 3. My x is a 4. We figure that one out. All right, again, doing the math. Let's see here. I got negative 3 times 4 is negative 12 plus 11. And, well, if you lose 12 and then get 11 back, you're still down 1. And there's the y-coordinate of my point of intersection. The only thing I got left over to do, the old therefore statement. Make sure you do this. Point of intersection is my x-coordinate is 4 and my y-coordinate is negative 1. And that is how we find the point of intersection by algebraically, which means using the equations. All right, is there any questions?